Welcome. Thank you for joining us today as I discuss the investigation of communicative flight paths for small unmanned aerial systems. This is Dr. Brittany Duncan presenting on behalf of the Nimbus Lab at the University of Nebraska-Lincoln. The motivation behind this work is that drones, or small unmanned aerial systems, are being used more frequently in public-facing applications and will need to communicate with those who may not be operating them. One example is in the prescribed fire domain shown at the right, but other domains include package delivery, photography, and agricultural applications where bystanders may need to be informed about something the drone knows. This work explores an initial set of gestures to understand whether 64 novice users on Mechanical Turk show broad agreement on what the gesture meant. It's explored whether they could apply a consistent label chosen between 7 or 2 of the following labels: lost signal, change position, landing, miss goal, draw attention, lost sensor, and low battery. In the 2-choice condition, 2 of those labels were presented. In the 7-choice condition, all 7 were presented. The participants then selected the one that best described the gesture they were currently seeing on the screen, and this is the result of that investigation. 32 participants were in each condition for a total of 64 participants from Mechanical Turk. Circle was labeled by 41% of the participants in the 7-choice condition as draw attention. Figure 8 was labeled as lost sensor by 84% in the 2 alternative condition and change position by 41% in the 7 alternative condition. Left-right showed low agreement from participants, though we thought it would look like the shaking of a head. There was no consistent agreement upon what this gesture might mean. Loop was labeled as landing by 34% of the participants in 2 alternative force choice. Spiral was labeled as landing by 88% of participants in 2 alternative force choice and 59 in 7 alternative force choice, meaning that it's a highly agreed upon label that could likely be used by practitioners in public-facing domains today. Swoop was labeled as draw attention by 75% of participants in the 2 alternative force choice. And undulate was labeled as draw attention by 34% of participants in the 7 alternative force choice. Finally, up-down again showed low agreement from participants, though we thought it would look like nodding. The primary finding of this work was that sUAS flight paths can be used to communicate information about the sUAS and its understanding of the world to diverse participants. Spiral and circle could likely be used today by developers in public-facing applications to communicate landing and draw attention respectively.